So for lesson 2, we're going to solve multiplicative comparison word problems by applying the area and perimeter formulas. So for number 1, we have a rectangular porch is 4 feet wide. It is 3 times as long as it is wide. So if this is our porch, we know that it's 4 feet wide. Okay. Now it's 3 times as long. Okay, so now our length is not 3, it's actually 3 times 4 feet. Okay, so we would label it actually like that. Now, to find the perimeter of the porch, we remember that perimeter equals 2 times length plus width. Okay, so now we know that our width is 4, because it says right there in the problem. But what we need to find the length. Okay, now if we go up to our diagram here, okay, our length then is these 3 4s, and we know that 3 times 4 is 12. Okay, so now our length here is 12. Okay. Then 12 plus 4 gets us 16. Okay, and we know that 2 times 16 is 32. Okay, so the perimeter equals 32 feet. Okay, moving on to number 2. I've already drawn the rectangular for this one. So now we have a narrow rectangular banner. It is 5 inches wide, and it is 6 times as long as it is wide. Okay, so we drew a diagram of the banner. Okay, so we know that the width is 5 inches. Okay, and the length is 6 times the width. So I've taken my banner here and I've divided it into 6 sections. Okay, and then each one of these is going to have a length of 5 inches. Okay. Alright, so now to label that total length, okay, we have 6 times 5, which gets us 30 inches. Okay, so the width is 5 and the length is 30 because of that 6 times 5. So now we're going to find the perimeter and area. Okay. We remember our formulas. We're going to make sure those are memorized. So let's do perimeter first. So we have 2 times. All right. So our length is 30. Our width is 5. Okay. Okay. So now we have 35 times 2. And we get a perimeter of 70 inches. Okay. Now we come over here to the area. Okay, so we know that the length is 30, width is 5, so we're doing 30 times 5. Okay, we know that 3 times 5 is 15, so 3 tens times 5 is 15 tens. So the area would then be 150 square inches. Okay. So now moving on here to number 3, we have another rectangle. Now this one has an area of 42 square centimeters. So this time they're giving us the area. Now its length is 7 centimeters. We need to find the width. Okay, so again we know the area is length times width. Okay, so our area is 42. We know length is 7. So we need to find the width. Okay. Well, 7 times what is 42? So we know the width is 6 centimeters. Okay. Now, Charlie wants to draw a second rectangle that is the same length, but is 3 times as wide. Draw and label Charlie's second rectangle. So we're going to keep the same length, okay, of 7. Okay, it says length is 7. Okay, now we're going to do 3 times as wide. Now, our width over here is 6. So we actually are going to do 3 6s. Okay, we have to read this one carefully because it's 3 times as wide. So this is slightly different than the first 2 problems we did. Okay, so now our total width now becomes 18 centimeters. Okay, so now we need the perimeter of this new rectangle. So again, we write out our formula. 2 times length plus width. So our length stayed at 7, but now our width became 18. Okay? So now we have 2 times 25. So our perimeter is 50 centimeters. Okay? All right, moving on to number 4. The area of Betsy's rectangular sandbox is 20 square feet. Okay, so they're giving us the area. The longer side measured 5 feet. Okay. Now, the sandbox at the park is twice as long and twice as wide as Betsy's. So we have 2 different sandboxes here. So letter A, we're going to start off with Betsy's sandbox. So we know the area is 20 square feet. And the longer side is 5 feet. Alright, so we need to find that missing side. So we know that area equals length times width. Okay, so we need to figure out 5 times what is 20. So that means our width is 4 feet. Okay, so now we can go to letter A, and now we find the perimeter. So we do perimeter equals 2 times length plus width. Okay, so we have our length of 5 and our width of 4. Okay, so we get 2 times 9, so our perimeter equals 18 feet. Okay, now moving on to our sandbox at the park. Okay, now we're going to draw a much larger one. So now the sandbox at the park is twice as long. So if our length is 5 feet, that means twice as long would be 5 feet and then another 5 feet. Okay. Now it's also twice as wide. So now I'm going to label the width with 4 feet and 4 feet. Okay, so you can see that we've taken the length and doubled it, and we've taken the width and doubled it. Okay. So now we find the new perimeter. Okay. So our length now becomes 5 plus 5, which is 10, and our width now becomes 4 plus 4, which is 8. Okay. So now we have 2 times 18. So now we have a perimeter of 36 feet. Okay. Now if you notice, our letter A, the perimeter for Betsy was 18, and letter B, at the park, now it's 36. So if we notice, if we double the length and we double the width, we're also doubling the perimeter. So if we take a look, what is the relationship between the 2 perimeters? Okay. So the perimeter of the park's sandbox is double the perimeter of Betsy's sandbox. Okay. Okay. Because 18 times 2 gets us 36. So, and there's Betsy, and there's the park. So letter D says, now find the area of the park's sandbox using the formula area equals length times width. Okay, so if we go back to our park sandbox, we know that now we have dimensions of 10 by 8. So now we're going to use 10 times 8 to find our area. So that gives us 80 square feet for the area of the park sandbox. So now the sandbox at the park has an area that is how many times that of Betsy's sandbox? Okay, so Betsy had an area that equaled 20 square feet. Now the park had an area, looking at what we just did in letter D, had an area of 80 square feet. So we need to figure out 20 times what gives us 80. Okay, well, I know that 2 times 4 is 8. So 2 tens times 4 is 8 tens. Okay. So the sandbox at the park is 4 times the area of Betsy's sandbox. Okay. Now our last one here, we're going to compare how the perimeter changed with how the area changed between the two sandboxes and explain what we notice. Okay. So, like what we talked about up here in letter C, okay, when the length and width are doubled, okay, we said that the perimeter is doubled. Okay. And if we take a look at what we did here in letter E, the area is multiplied by 4. Okay, so when we double the length and the width, that doubles the area. Okay, but because area uses multiplication in its formula, now the area gets quadrupled.